The Royal Academy presenting Tnpsc Group 1 for GO, IAS and IPS 2023 preliminary exam. This is Unit 1 General Science Part 3. In this class we are going to see general scientific laws. First law is Archimedes' law. Archimedes' principle states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. Archimedes' principle is a law of basic fundamental to fluid mechanics. Next law is law of flotation. Any object totally or partially immersed in a fluid or liquid is buoyant up by a force equal to the weight of the fluid displaced by the object. These two are more or less same. And next one is Snell's law. To describe the relationship between the angles of incident and refraction when referring to light or other waves passing through a boundary between two different isotropic media such as water, glass or air. Snell's law is defined as the ratio of the sine of the angle of incident to the sine of the angle of refraction is a constant for the light of a given color and for the given pair of media. Snell's law formula is expressed as where I is the angle of incident and R is the angle of refraction. This constant value is called the refractive index of the second medium with respect to the first. See, this picture shows the Archimedes principle very clearly. An object is hanging in the weighing machine. It weighs about 7 pounds. IB means pounds. Okay. Now it is immersed inside the liquid or any fluid. Okay. This object replaces 3 pounds of water. So it replaces 3 pounds of water. This is the buoyant force of the liquid. Okay, so what is the Archimedes principle in the sense that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. So this body displaces 3 pounds of water. Okay. So this is Archimedes' principle. Next one is laws of flotation. What is laws of flotation? Flotation means any object which float on any liquid or fluid. Okay, that is called as law of flotation. So how it happens in the sense when any object placed on the water or any liquid or any fluid, a certain part will immerse inside and fully it won't immerse. That is because of the buoyancy force exerted by the liquid or any fluid. Okay, so this force is equal to the weight of the fluid displaced by the object. That is called laws of flotation. You can find here a certain part of this ship is inserted in the water and 3/4 of the object is outside. This is due to the force exerted by the liquid or the water or any other fluid. That force is called as buoyancy force. Due to this buoyancy force only the ship or boat are floating on the water. See Snell's law. What is Snell's law? The ratio of the sine of an angle of incident. This is the angle of incident and this is the angle of refraction. Okay. So here it is mentioned as theta 2 and this is theta 1. Okay. So Snell's law is n1 sine theta 1 is equal to n2 sine theta 2. Okay. So where this is called as I. I is the angle of incidence and R is the angle of refraction. This is the angle of refraction. This constant value is called refractive index. This constant value is called as refractive index of the second medium with respect to the first one. Newton's 3 laws. Newton's first law. Every object continues its state of rest or state of motion until an external force acts on it. The second law is the rate of change of the momentum of a body is equal to magnitude and direction of the force imposed on it. That is, F is equal to ma. Newton's third law. For every action, there is an equal and opposite reaction. This picture clearly mentions the three laws of Newton. See, you can see here the object is at rest, will remain at rest. He's just pushing, so it moves slightly. Here, he is giving a force continuously, so the object from here, it moves there. Okay. Second law, see, the acceleration of an object depends on the mass of the object and the amount of force applied. So a continuous application of a force makes the object to move continuously. That is called as acceleration. Third law, for each and every action, there is an equal and opposite reaction. See, he is pushing here, so again he is pushing. So the same equal force is applied here and from here. So this is called Newton's third law of motion. Let us see the next law, law of conservation of energy. The law of conservation of energy says that energy is neither created nor destroyed. The energy changes from one form to another form. Boyle's law. Boyle's law is gas law. The absolute pressure exerted by a given mass of an ideal gas is inversely proportional to the volume it occupies if the temperature and amount of gas remains unchanged within a closed system. Charles' law 1. The volume occupied by a fixed amount of gas is directly proportional to its absolute temperature and if the pressure remains constant. This is the volume of gas at constant temperature is directly proportional to its absolute temperature. Next law is Octavus. If the chemical elements are arranged as per increasing atomic weight, those with similar physical and chemical properties occur after each interval of 7 elements. This we can see in a picture. This is Boyle's law. So you can see here there is a cylinder with piston. Here also a cylinder with piston. What is happening in between these two in the sense? Here the pressure is less, whereas here we are applying more pressure. When there is more pressure, automatically the volume of gas decreases and pressure increases. Here the volume increases and pressure decreases. This is Boyle's law. Next one, if you see Charles' law, when the pressure is constant, the volume is also constant. Whereas if the air is heated or the gas is heated, its volume increases. That is the difference between Boyle's law and Charles' law. Here we are applying pressure, here we are heating or increasing the temperature. Law of Octavus. According to the Newton's law of Octavus, when elements are arranged in order of their increasing atomic mass, the properties of every 8th element are similar to the first. You can see this one. Okay, this is similar to sodium. This is similar to magnesium. This is similar to aluminium. This is similar to silicon. So like that, if we arrange in order of their increasing atomic mass, the properties of every 8th element are similar to the first one. That is what law of Octavus. Let us see Keplers law. Keplers first law. The orbit of every planet is an ellipse with the sun at one of two foci. Keplers second law. A line joining a planet and the sun sweeps out equal areas during equal intervals of time. Keplers third law. The ratio of the square of an object's orbital period with the cube of the semi-major axis of its orbit is the same for all objects orbiting the same primary. You can see the first law. The orbit of every planet is an elliptic with sun at one foci. See, sun is here. The path of the planet is elliptical. Okay. Second law. A line joining a planet and the sun sweeps out equal areas during equal intervals of time. You can see here, okay, this area is equally proportional to this area. Okay. And why? In the sense, when the planet comes nearer to the sun, it moves very fast. Whereas the planet which is away from the sun, which moves very slowly. So this area covered by the planet is same, okay, is proportionally equal. This area and this area are proportionally equal. This is second law of Kepler. Third law, the ratio of the square of an object's orbital period with the cube of the semi-major axis of its orbit is the same for all objects orbiting the same primary. Okay, so this is the third Kepler's law. The universal law of gravitation. Newton's universal law of gravitation states that every particle attracts every other particle in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Bernoulli's principle states that in fluid dynamics, an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid's potential energy. 12th one, lens formula. If the distance from the object to the lens and from the lens to the image are S1 and S2 respectively, for a lens of a negligible thickness, that is thin lens, in air the distance are related by the thin lens formula, that is 1 by f is equal to 1 by S1 plus 1 by S2. Bernoulli's principle states that in fluid dynamics, an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or a decrease in a fluid's potential energy. Coulomb's law. Coulomb's law. The force of attraction or repulsion acting along a straight line between two electric charges is directly proportional to the product of the charges and inversely to the square of the distance between them. Ohm's law. The current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance. I is equal to V by R. Pascal's law. In a fluid, gas or liquid, at rest in a closed container, a pressure change in one part is transmitted without loss to every portion of the fluid and to the walls of the container. This is Coulomb's law. These particles are charged particles. The force of attraction or the repulsion acting along a straight line between two electric charges is directly proportional to the product of the charges and inversely to the square of the distance between them. Okay, F is equal to K Q1 Q2 by T2. This is the formula. Now see Ohm's law. I is equal to V by R. That is electric current is equal to voltage by resistance. Pascal's law. In a fluid at rest in a closed container, a pressure change in one part is transmitted without loss to every portion of the fluid and to the walls of the container. You can see here there are two pistons. This is smaller in size and this is bigger in size. The pressure or force is applied here. This piston pushes downwards in the sense it creates a pressure. That pressure is without any loss of energy. It moves throughout the container as well as it exerts the pressure on the walls also. Now due to this pressure, the small pressure we apply makes a bigger object to push upward. This is Pascal's law. Avogadro's law. Under the same conditions of temperature and pressure, equal volumes of different gases contain an equal number of molecules. The specific number of molecules in 1 gram mole of a substance defined as the molecular weight in grams is 6.02214076 into 10 raised to 23. A quantity called Avogadro's number or the Avogadro constant. Brownian motion. It is a random motion of particles suspended in liquid or gas that results with the fast moving atoms or molecules in the gas or liquid. Example, motion of pollen grains on still water and motion of dust particles in room seen in sunlight. Raman effect. Raman scattering or Raman's effect is an inelastic scattering of photons by matter, meaning that there is both an exchange of energy and a change in the light's direction. See Avogadro's law. Under the same condition of the temperature and pressure, equal volumes of different gases contain an equal number of molecules. The specific number of molecules in 1 gram mole of a substance defined as the molecular weight in grams, a quantity called Avogadro's number or the Avogadro constant. See, this is the gas or a liquid. When we push down or we apply pressure, the volume decreases. The volume decreases, but the weight remains same. Brownian motion. In a random motion of particles suspended in a liquid or gas that results with a fast moving atom or molecules in the gas or liquid. Okay. See, these are the motions or a movement of the pollen grains in the water as well as the dust particles in the air in the room. They continuously move. Let us see the Raman effect. This is when a light is passed through this, the light particles, they scatter. So this is called as Raman effect. Raman was the first Indian Nobel Prize winner in 1930 in the field of science, and what unique about him is that he got the prize for work done in India at the Indian Association for the Cultivation of Science, Calcutta. And this is Raman effect, is an inelastic scattering of photons by matter, meaning that there is both an exchange of energy and a change in the light's direction. See, this is a prism. When a light passes through this, in the sense, when it comes out, it scatters like this. So this is called as Raman effect. Thanks for watching and subscribing this channel. Continuously watch this channel for further videos and subscribe this channel as well as share these videos to your friends, those who are preparing for IAS, IPS, DO for Group 1, and also send this video to the people, those who are preparing for 10th, 11th and 12th board examination of CBSE and ICSE and also international syllabus. Thank you so much.